Hi, and welcome to this first video on functions at GCSE, but only at a fairly superficial level. So what we're going to be doing at A level is looking at it in a lot more kind of technical detail and with a lot more complex functions and really getting into the kind of the nuts and bolts of what goes on with these things. So we've got a lot to get through. So we've got differences between mappings and a function, what a function actually is. We've got domain and range, which are terms you should be familiar with, and then exclusions to those domains and ranges. Inverses, the graphical relationships, and then finally composite functions. And again, that is essentially GCSE, but we're going to do it in a much more in-depth way. So here we go. First things first, let's have a look at what the difference is between a mapping and a function and start talking a little bit about domains and ranges. Now, let's say there's a lot of kind of definition stuff going on in here, so you'll have to bear with me, but it is important stuff that you need to know about. So here we go. So what we've got is a mapping, which essentially just transforms a set of numbers into a different set according to a rule. And you might be thinking, well, that's what a function is, but a function has a slightly more technical version, as we'll see in a second. So that might be a mapping. So you've got the rule, you've got to take the number that's on the left-hand side here, times it by 4, add 1, you get the numbers that are on the right. Or we could get something like that involves a squaring. So that one's saying we've got to square the number and then subtract 3. Down here, we've got one with the square roots. And finally, we've got the one that's the function that's the sine of the angle. And straight away you can see from here that kind of all these functions have got slightly different characteristics. I said this one, nice and straightforward. Here we've got different values coming from the same number. Here we've got kind of two values giving the same output and so on. So they've all got slightly different characteristics as mappings, and it's these characteristics that determine whether or not these things are referred to as functions or not. Now, some of these things have got restrictions on what values we can put in. So, for example, if we take our square roots, we can't put -9 into the function because we can't have a square root of a minus, so we'd never get anything out, so we're not allowed to put a negative into it. So there's a restriction on what can go into the function. Whereas over here, you should be familiar with the sine function and know that whatever value you put in, you're only going to get values out that are between -1 and +1. So you can't put a value into a sine function and get a value of maybe 2 or 3 and so on. So there is a restriction in this case on what we can get out of the function. And again, that links into our definition of what a function actually is. The input values we refer to as the domain, and the output values we refer to as the range. And hopefully those are two terms that you're familiar with. Right, so here we're getting on to what a function actually is. So a function is a specific kind of mapping, and it's a mapping where each value in the domain is mapped to exactly one member in the range. And these can essentially come in two forms. The first form is what we call a one-to-one mapping, a one-to-one function, where each individual value in the domain maps to an individual value in the range. Nice and straightforward. Or we've got a many-to-one. And many-to-one means that you've got many values, multiple values over here in the domain that map to a single value over here in the range. So we've got one-to-one, many-to-one. The key thing being it's got to be to one. There's got to be one specific value that's got to come out for each value that you put in. If then we consider our square root function, what we've got here is not a function, because when you put 16 in, you can get 2 out. So this thing is technically referred to as one-to-many, which is the reverse of this one, which is many-to-one. This one is one-to-many, and so therefore it is not a function. It's a mapping, but it's not a function. What we can do, though, is put a restriction on the range, and therefore that would make it a function, but that's a story that's going to come later. So for now, we're saying, well, because it is one-to-many, it is not technically a function. These two are functions, this one is not. Right, on we go. So let's just have a think about the link between what we just saw there on our diagrams to what these things actually look like if you start plotting them on a graph. And that helps you to become clear on this definition of what is and isn't a function. So, essentially, if you can draw a vertical line on the graph at any point and it only hits the curve once, then it meets the definition of a function. And so let's have a look at what I mean by that. So there is our y equals 4x plus 1. So our first function from the previous slide was 4x plus 1. And if I draw a vertical line up anywhere, I'm only going to hit the line once. So you can see for any single value that I put in, so here I'm putting in a value that's around about 3, getting out one value. Here I'm putting in the value that's just over minus 2, getting out a single value. So we've got these vertical lines and they're hitting the graph once. Okay, so therefore what we've got is a function. That one was one-to-one. If we have a look at how that works now on a one-to-many, again the same principle applies. If I just draw a vertical line, if I've drawn that up somewhere between 3 and 4, it's hitting that curve once. If I do the same thing on the other side, but again draw a vertical line, it still only hits the curve once. Yes, it's spitting out essentially exactly the same value, but that vertical line rule still holds. I'm only getting one value when I draw a line vertically up, so I'm only getting one value for each individual x value. That value can come out, can be the same for more than one x value, but is unique to that particular value. However, if we take our square root graph and I do the whole vertical line thing, you can see straight away, there you go, it's giving two possible values because the green dotted line is hitting the curve twice, and so therefore that means it's not a function. And so I think that's probably the easiest way to think about whether things are or aren't functions in terms of like this vertical line idea. Right, on we go. Let's talk a little bit about notation now. So we had before our very basic definition of, I've got to take a number over here, times by 4, add 1, and what I get out on the other side. But to describe this as a function, we'd write it like that. Or alternatively, you sometimes see this notation. Now, I've got to be honest, I don't particularly like that one. That's just my personal preference. Throughout the slides, I'll be working with this one over here. But if you do see something that looks like a bit like that, it means exactly the same thing. So what we're saying is, we're going to take some function, we're going to call f, we're going to put in a value, and whatever value we do, what we get is to do 4 times that value and then add 1. And again, hopefully that's an idea that you're familiar with from GCSE. So if we're going to describe what values we can have as a domain, it's described in terms of what values can be put into here. And so for this one, we're saying that x, this symbol here means belongs to, and this symbol here means the real numbers. Now, real numbers is basically absolutely anything that could be on a number line. It could be whole numbers, it can be negatives, it could be positives, it could be decimals, recurring decimals, non-recurring decimals, absolutely any number that you can think of on a number line. So we can put absolutely anything into here, and what can we get out? Is there any limit on what we can get out? Well, as it turns out, absolutely not. The domain y is belonging to the reals, or we could say that f of x belongs to the reals. So the distinction here is that if we're going to describe the domain, it's in terms of x. If we're going to describe the range, it's in terms of either y or f of x. Now, a function can be defined using different rules for different values of the domain. So it doesn't have to be the same rule for every single value with the domain. So what we could have is something that looks like this. So what we've got is for any value of x that's less than 2, this is what we have to do to it. For any value that's more than 2, equal to or more than 2, this is what we're going to do to it. So what that looks like would be that. So here's our 6 minus 2x for all the values of x that are less than 2. And here is the second part, which is 2e to the x minus 2. So essentially two different curves that are kind of spliced together to make a single function. So if we're thinking now, what's the domain of this function? Well, the domain here, you can see it here, is absolutely any value at all. So the domain can be x belongs to the reals. And what's happening with the range on this one? Well, you can see graphically here, the range is the y values. So if we look at it, it's anything from y equal greater than 2 upwards. The smallest value we can ever get out of this function here is y equals 2. And that's occurring, as it turns out, when x equals 2. But you can see the y values can only be equal to or bigger than 2. So graphically, range and domain, it's sometimes easy to see if you kind of draw it on a graph. I've got the range on here being the y values, the domain would be the x values. If we take a look at another function, again, it's another one that's got these kind of different rules for different values within the domain. And you'll notice what I've got this time is essentially a function that's got a break in it because the lines don't join at the point when x equals 4. And again, you'll notice what we've got is the use of the kind of the inequalities. So for this section here, that's equal to or greater than 4. That's why it's coloured in. For this section here, x is strictly less than 4. So if I put 4 into this function, I'd be putting it into this part of it because that's one that says where x is equal to 4. So that means it's still a function. If we had an overlap, then I could get, if I put x, so if this one here said x equal to or less than 4, then if I drew my vertical line up, I'd be getting two different values out, so it wouldn't be a function anymore. So that's why with these things we've got to be very careful with how we define them using the inequalities. The domain for this one, again, x can be absolutely anything, and if you have a look at the range, in this particular case, the range cannot be anything bigger than 6, so the range is y equal to or less than 6. Okay, so on we go. On the last slide, we saw a couple of examples where there was only certain values that you could get for the range, so the range was restricted. Let's have a look now at functions where we've got restrictions on the domain. So we've got three functions here, and we've got to state the domain and range for each of the following. Now the first one, this is what I mentioned earlier, where if we restrict the range and say, okay, we can only take the positive square root, that now makes this a function, because this is now becoming a one-to-one function. Now let's have a little look at the graph of that one. There it is. That's at y equals 2x minus 3. And already from that graph you can see there's limits to what values of x I can put in, and there's also going to be limits to what values of y we can put in as well. And we should know that for a square root, you can't put a minus value into a square root. So that means we've got to have 2x minus 3. The bit underneath the square root has got to be bigger, equal to, or bigger than 0. So if we solve that inequality, we get x is 3 over 2. And so that means our domain is just these values here. The domain is any value as long as it's equal to or bigger than 3 over 2. In terms of the range, because we're only taking the positive values, what we've got is a range of y is equal to or greater than 0, where y belongs to the reals as well. So on that one, we've got restrictions on range and domain. Let's have a look at the next one. So there it is. This is g of x, which is 1 over x plus 5 minus 3. And again, we can see that what values of x can we put in? Well, it's going to be absolutely anything. We can have negative values, positive values, but the things we can't have is just a particular value here. And we know that for a fraction, 1 divided by 0 is undefined, so we can't have a 0 on the bottom, so x cannot equal 5. So what we say is that x belongs to the reals, can be absolutely anything at all, except it can't be minus 5. In terms of the range, now again we've got an asymptote on our graph here. Essentially what's going on is that if we're taking the value of minus 3 and then we're putting this fraction, either adding it on or taking it away, so what that means is the value of my function can never actually be minus 3. So we've got a similar thing going on with how we describe the range. Y can be absolutely any value at all, but it cannot be minus 3. And on we go to our third example. So we've got h of x equals ln 3 minus x. We've got a log function where we're using the base of the natural logarithm. So there it is on the graph. And so you can see there's certain values of x that can't go in there. And the reason for that is we know that the ln function is undefined for 0 or negative values. So you can't have ln 0, you can't have ln of a minus number. And so what that means is that if we look at what's going on up here, that means 3 take away x can't be equal to or less than 0. So that means x has got to be less than 3. And so there's our domain. So x can belong to the reals, x belongs to the reals, but x has got to be less than 3. If we have a look at what's going on with the range is the y values, and you can see from the graph it can take absolutely anything, so y belongs to the reals, and there's no restrictions on the range for this particular function. Okay, on we go. So that's restricted, range and domain. Let's just have a look at a couple of quick examples, and then we will finish for that. So here we go. So we've got a function f of x equals x plus 3 over x minus 1. The first one is just plug a value into a function. What do we get out? So f of 6, that would be 6 plus 3 over 6 minus 1, which is just 9 over 5. Nice and straightforward. Here what we were being asked to do is, let's say, well, we're putting a value a into a function, and we're getting 3/4 out of the function. So what value would we have to put in order to get 3/4 back out? And the way I'd go about that one is saying, well, f of a would be this thing. If this thing over here is f of x, then f of a is exactly the same thing, but with a's instead of the x's. So all I'm going to do is write a plus 3 over a minus 1 equals to that. So essentially I'm substituting this thing here with a plus 3 over a minus 1. There it is. Do a bit of cross multiplying, you get that. Multiply out the brackets, do a bit of tidying up, and we end up with a value of a, which is minus 15. Okay, and the third example, we've got f of x equals x. So again, what we're saying is, what value do we put into the function such that we get exactly the same value coming out of the function? So again, what I'm going to do is just take my f of x here and replace it with my definition, which is this thing here. So we've got x plus 3 over x minus 1 equals x. Multiply out, it turns into a quadratic, set it equal to 0, do some solving, and there we go, we've got two values. Second example I'm going to do, so we've got another function, g of x. So this was a function that we saw earlier on in the slides. So it's one of these ones where we've got a kind of split domain. So what we do is different depending on where our value is that we're going to put in. So first of all, g of 3. So g of 3, well 3 is greater than 2, so it's going to have to go into this part of the function. So that's going to be 2 to the power 3 minus 2, which is 2e. That's that bit done. And let's flip that around and say, okay, well, what value can we put into the function such that we get a value of 3 coming out of the function? Well, let's just see what happens if we put it into both bits. So let's start off by putting it into that side of the function. So we've got 6 minus 2x equals 3. So that gives a value of x equals 1.5. Now we've just got to pause for a second and say, well, is that valid for the particular domain that I was looking at? Well, yes, because it's less than 2, that means that works. So that one's absolutely fine. And let's now see what happens when we put it into the other part and see if we get a valid value coming out of there. So with there, 2e to the x minus 2 equals 3. Move the 2 over, take logs, and then solve it. And there we've got x is 3 over 2, ln 3 over 2 plus 2. And you'll see that that fits with this definition. It's bigger than 2 because it's 2 plus ln 3 over 2. So what we've got is two values coming out of there, both of which are perfectly acceptable. Okay, job done.